Welcome to Digital Futures Education. Today we're going to go over Lesson 2 content for the CompTIA A+ exam. So as we watch and listen, I'm going to review the lesson content for Lesson 2 of the CompTIA. So in Chapter 2 of this CompTIA lesson, we're going to be going to installing system devices. And we're going to review a lot of concepts here. So let's get started.
We're going to installing system devices. So just to give you a little big picture here, I didn't show you necessarily like this part of the portal, but this is something to pay attention to. So I want to give little tips as we go through, things to notice. So with Lesson 2, installing system devices, the topics are listed here too. So there's configuring power supplies, install storage devices, configure system memory, install and configure CPUs. So there's going to be in Lesson 2 those 4 areas. And within those 4 areas, you have the components of the lesson. So let's go ahead and dive in a little bit. So this installing system devices, the market for system components of a personal computer is a complex. Processors, memories, models, disk drives, and power supplies are advertised as a bewildering range of technology. It often is. I'm just going to zoom in so you can see a little better. As a CompTIA technician, you need to interpret the performance characteristics of how processing, storage, and power components contribute to a PC specification. So we're going to learn how does system devices contribute to understanding how a computer works. And so there's power supplies and cooling, what type of storage you need on a device, what type of memory is used, and configuring a CPU. And as we learned in our last class, what is a CPU? I'll ask the class, what's a CPU?
Central processor.
Yep, exactly. CPU is central processing unit. And we learned in the last class, it's attached to the motherboard, and it's an important part. So if I'm going to put myself medium. Remember, when you put yourself medium, it basically lets you know where do you start. And I'll remind you of your confidence levels here. Let me go back to system devices, move me out of there. All right. So let's get into this. And then I'll show you my mood board. And then maybe we'll make a mood board of our own in the next class. But I did show you the mood board. So the objective here, install and configure power supplies and cooling, given a scenario. So when they say given a scenario, they're actually referencing the fact of the troubleshooting methodology, that you're going to be given a scenario which could have different questions about what's happening, and install and configure motherboards, central processing units, CPUs, and add-ons. And then another potential scenario could be installing or replacing the power supply. So that's a core 1 objective. So what they mean by a core 1 objective is on the core 1 test, they're going to give you a question that has a scenario in which you're going to need to do or choose the right answer according to those 2 situations. So, all right. And that's the ESD, but we're going to see that in just a minute. So the power supply of a computer, it's usually the big fan located, installed off the motherboard or onto the side of the case. It delivers current, DC, low voltage power to the PC. It contains a rectifier to convert the alternating AC power to DC voltage output, transformers to step down to lower voltages, and filters and regulators to ensure consistent output voltage. The other important components in the PCU is the fan, which dissipates the heat. Does anyone know of another way, and it's in CompTIA, that you can cool a computer other than a fan? What's another method for cooling?
Liquid cooling?
Yep, you could use water cooling system, and they mentioned that. And the goal is, and what's the obvious reason that we need to cool a computer?
So it won't overheat?
Yep, it won't overheat. I work in K-12 schools, and we have a lot of Chromebooks. And actually, as the Chromebooks get older, their operating systems, they're little tiny brains that run the Chromebooks. The kids' Chromebooks, reasons why Chromebooks sometimes start on fire in schools and things, and they have issues with melting, is because they're older Chromebooks, but they're accessing resources on the web that are so much newer than the motherboard in the Chromebook. So what happens is they start to get really, really hot to the point they'll even melt because they don't have enough cooling built for their age. And maybe you had an experience with your phone in the past, your phone overheating. A lot of that can be doing with the resources of you multitasking on the web, doing lots of different stuff, and then it not dissipating the heat. And that's the importance of cooling. So this would be a picture. I think I added it to the vision board. It has to be on the vision board because AC voltage varies by country in the age of AC distribution circuits. PSUs, power supply units, have a wide tolerance in each band. The low line range is 100 to 127 VAC, while the high line range is 220 to 240. So this is an older, larger fan cooling unit for a PC, auto switching PC. And then it has the Molex connectors. We were introduced to Molex, so all right. Wattage rated. So we'll go right here. We don't have to read the whole thing, but let's check out. It's the measure of how power can be supplied. So the power requirement of different components varies widely. For example, CPUs can range from 17 watts to over 100 watts, depending on the model. And just like with the Chromebook that I was talking about, those are tiny little brains. They're not going to be able to handle certain types of scenarios. Same with our phones. And the reason why you have water cooling systems is on a lot of gaming machines, because their graphics card and their processor are running very high level graphics. So all of that requires more power and more cooling. The power output is not the same as the power the PSU draws from grid power. If a PSU works at around 75% efficiency, a 300 watt power supply would draw 400 watts from the outlet. The energy loss is mainly as energy becomes more expensive, both in terms of cost, in terms of climate. Power efficiency is an important criterion to use when selecting a PSU. An Energy Star 80 plus compliant PSU must be 80% efficient at 20 to 100% of the load. So here is just a chart when specifying a power supply unit for a system with high power requirements. It's important to assess the power distribution for its output voltages. Distribution refers to how much power is supplied over each rail. A rail is a wire providing current at a particular voltage. The following table shows an example of how the power distribution for a PSU might be configured. So there's the output rail, the maximum load, and the maximum output. So they have a note here that the output of a 3.3 volt and plus 5 volt has a combined limit. For a modern computer, the output rating of the plus 12 VDC rail or rails is the most important factor, as plus 12 VDC is the most heavily used. So this will become a little, we're going to probably have a question or two that just we have to break this idea down. And it's essentially so that you can understand the necessity of voltage and power supply. Just a component of that. So the power supply connectors supply DC voltage to motherboards at 3.3 VDC, 5 VDC, and 12 VDC. Not all components use power at precisely these voltages. So the motherboard's power port is referred to as the P1 connector. A PSU will also have a number of Molex and or SATA device power connectors and 4, 6, 8 pin connectors for use with CPU and PCIe adapter. So we talked about a little bit of PCIe last night. And then we have the 20 to 24 pin motherboard adapter. And then the ATX PSU standard. After Tuesday's class, what do we know is what can we assume is the ATX PSU standard? Not necessarily the number, but what does ATX stand for? You remember?
It was a certain size for the motherboard.
Yep, it's the size of the standardized size for a motherboard. Remember, there's a mini ATX, and they come in different sizes. So the reason why I just mentioned that is because it says ATX PSU standard. So it's standardizing that power supply unit at that size. It's gone through, so the regular average size, really. The P1 connector is a 20 pin, black wires, insulation of ground, yellow RV, red are 5 volt, and orange are 3.3 V. Most systems are now based on the ATX V version 2. This defines a 24-pin, 2x12 P1 form factor to replace the 20-pin one. So 2, 4, 6, 8, 10, 12, 14, 16, 18. So that's 24. Then the P1 adapter for compatibility with older motherboards is a 20-pin port. So this would be probably the most important note related to this right now, because we're learning about how many pins. We might get a question. All right, on a ATX standard board, the P1 connector is 20 pin, and they told us what that is. And they said that most systems are now based on the ATX 12V version 2. This defines a 24 pin, 2x12 P1 form factor to replace the 20 pin one. Some PSU. So what was the term that we could say? It's a term about technology, and we mentioned in the first class, it begins with an L, that we would call the 20 pin one. What type of technology? Remember? Does anyone remember? Legacy. Remember when we talked about the term legacy? Does anyone remember what legacy means in terms of technology? It's a good term to know for CompTIA because it's going to help you on different questions. Someone's going to say legacy, and you're going to have to be, someone's going to give you a scenario, and as part of the scenario, they're going to say, oh, that's legacy. This is why it's valuable to go through the question sometimes with the reading like other people too, because if you overlook a term, but it's an important term, and then you get a question right, you end up having to study it again. So someone tell me what legacy means in technology. You could have it in not technology, but it's referenced in technology all the time. What's it? And it'll help. This is to help. What's that?
Something that was used previously, but not anymore.
Yep, it's basically USB 2.0 is slowly becoming legacy. What color is USB 3.0's port on your computers? Does anyone know the difference? I just want to point out little things so you can see it on your own computers. You all have USB ports on your computer.
So there's a difference between the white and blue?
Yes. So the white is the legacy. You could consider it legacy. It's not really legacy because a lot of people still use it. But with more USB-C being used for things, USB is slowly becoming legacy. USB 3.0 is the blue one. You'll often see on older computers, you might have both, but the blue ones are on the back and the other ones are on the front. And then on newer computers, they might all be blue, or you might just have one of each or different spots. And so the difference is USB, the dark colored one or the white one is just regular USB like the first one. Then 2.0, I think it's 2.0, not 3.0, is it just provides more power. It's slightly more powerful. So say you're charging your phone, right? And you have the choice between ports. If you're going to charge your phone or plug in a mouse on a port, you'd want to plug your phone into the blue one and put the mouse into the other one. Because the mouse is going to work on the amount of power off the regular one no matter what. So that's your tech tip for the day. That's like, if you weren't familiar with that. So that's a simple way when you're looking at a computer to start being like, oh, that's legacy. And then if on the back of your computer, you have a VGA, that's even an older computer, or your monitor is connected with an older connector. But my point is just to get the term legacy, because you're going to see it in different questions across the program. So when you hear the term legacy, remember that it's usually the piece of technology that's being replaced. And so the important part of that is you're going to, when they say, oh, a scenario, the IT technician is looking to replace the legacy cable on this desktop computer that provides the image to the monitor. So they'll write up a scenario. And so your choice might depend on the use of that word. So it helps you break down a scenario. We'll see it more and more. So when something's being replaced like this, 20 pin, they're talking about adapters, compatibility, that's what's happening. And then we have modular power supplies. What's the term, before we even look at this, whenever you see the term modular, what do you think, when you think of modular, what do you think of? There's modular homes, there's, what else uses that term? Things that keep us the same. We have the same students. So modular, whenever you see modular, it's usually something designed so that it can be used similarly in different types of shaped scenarios. So like, if, the reason why they build modular homes in rectangles is you can put 100 rectangles next to each other of a certain size, and people like rectangles. If they like to live in circles, they put circles next to each other 100 times. So when we look at modular related to power supplies, it's a square shape and it's detachable from the unit, which means that the cabling and the organization of the parts of the module are all self-contained. So if you wanted to upgrade the fan to this computer, it would be easier than a fan that's been screwed into the case as much, because all the cabling and these wires are all self-contained. So they say PSU design where power cables can be attached to ports on the unit as needed. My puppy dog's saying hi to me. All right, hold on. So you'll see that, and it has 2-pin, 24-pin. If you see the little picture here, it says 24-pin ATX, peripheral and SATA. They actually have the cords described so that you can plug those cords in directly to your motherboard. And that's different than this, well, the page before this one. So these cables aren't so as organized. These cables are, this is what you call the cheaper version. Modular is definitely a little more expensive because you can use it for different things if you wanted to. This one is a little cheaper, and it probably has a couple extra connectors in case that it didn't fit your computer the same way. It comes with a backup plan. Maybe your motherboard is a little different. Maybe it's a little different. So that's a modular one. Redundant. So we could read it, but I'm going to ask the group. I want the dog whoa. I forced my dog into the room with me. So I'm nuts. What does redundancy mean? Repetitive. What else? When something's redundant, yes, I could be, if I keep talking about power supplies, eventually I will be redundant. But what's good about redundant with technology?
It doesn't change.
It can change. It just might do what that would be helpful. It will have, the word I'm thinking of is 2 words, and the first word starts with the letter B. So when you have redundancy, you have a backup. And we're going to talk a little bit more about redundancy in this unit because it has a section on data backups. So redundant power supplies, a computer system may be fitted with 2 PSUs, one acting as a failover. So redundancy is a system case configuration supporting 2 power units. And then here's another tech term, fault tolerance. What's fault tolerance? I hope as my students, and if I make a mistake, you have some fault tolerance with me.
Room for improvement?
What's that?
Room for improvement?
No, because that would be more on me. Fault tolerance would be like, even though something failed, there was a backup. So basically fault tolerance would be, all right, system supporting 2 power for fault tolerance. So it's a way of describing the backup. So in technology terms, if something fails, it can be referred to as a fault. So if the fault happens, basically there's some tolerance for it. So it's not the end of the world. So if this fan fails.
It's like a room for failure?
Yep, exactly. Room for failure. Yep, is another way of saying it. So this one has a redundant power supply, And so they're saying is like, since it has a redundant power supply, the system case configuration, which is like how they built the computer, supports two different power units. So if one fails, you have the other one. So it basically a backup plan if something fails. Also, it allows you to have the security that if something goes wrong, there's a solution right there. And then we have fan cooling systems. So components in a computer system emit heat because some hot degree of resistance when electrical current passes through them. Without a cooling solution, the heat will raise the temperature of each component and increase the ambient temperature inside the case. Ambient temperature is a temperature just all around, from the different parts. Excessive temperatures can cause the components to malfunction or even melt. This particularly affects CPUs, while Intel and AMD are both focusing on making new CPU designs more thermally efficient. All CPUs require cooling to keep the temperature within an acceptable operating range. So why is it essential to keep the CPU at a good temperature? Why are we so worried about the CPU?
Do we need to keep the brain going?
It's the brain of the computer. It's like if you're out on a hot day and you've been in the heat all day and you start to go insane because the heat's too much, you're not going to function very well, right? So it's all about keeping that brain going and healthy and being working the right way. So this is like an important little diagram. So we have heat sinks and thermal paste. And when we take a computer apart, which hopefully we're going to do in one of our boot camps, we're going to take a computer apart. And when we do, we're going to rip the motherboard off and you're going to see what's left of the thermal paste. So a heat sink is a cooling device fitted to PC components to optimize heat transfer. So this is not a good picture of a heat sink. Let me show you some better pictures. The fin exposes to a larger surface to the air around the component to achieve cooling by convection. The heat sink is affixed to the surface of the chip using thermal paste to ensure the best transfer of heat by eliminating small air gaps. A thermal pad performs a similar function. The pad is a compound that is solid at room temperature, but soft heated. So we're making a little sandwich here. So what is the CPU socket? What's the role of the CPU socket on the computer? Do anyone remember from last night? From Tuesday?
Where you plug the CPU into the motherboard?
Yeah, you can pop the CPU right into the motherboard. So it's like a square, it's kind of like a helicopter pad for the CPU, a square area where you can see the CPU. And sometimes they have clips and sometimes they don't. And then you have the CPU, which goes down right on top of this. And then you have, on this particular design, you have a fan, and then you have this lock that's going to go on top of the CPU. So the design here, which is one type of design, is, and you're going to see this in person, we'll talk about it in person, is you have this where you have, this is on the motherboard, the CPU socket. The CPU goes in the socket. On top of the CPU socket is this little metal thing that has a fan and it has a heat sink. You're going to have some thermal paste. This is where the thermal paste is going to go. And the thermal paste is going to take, so as this computer heats up and the CPU starts to be used, it's going to create a lot of heat. And when it creates a lot of heat, it's going to have to dissipate that heat. So what they say here is cooling by convection. So it's going to take the heat that comes off of this CPU and it's going to go up into this metal thing here that I'm going to show you a better picture of, called a heat sink. And there's a fan connected. It looks like there's a fan connected to the heat sink that's going to blow the heat that goes into the heat sink. Let me show you a better picture of a heat sink. So you go into Google heat sink. I'll show you. Oh my goodness, they've changed a lot. I'll do heat sink motherboard. Let me share my screen. So when we rip open a computer, and look at a motherboard, and this is a good example because it looks like what we're dealing with. And this is Wikipedia under heatsink, but let's take a look. I wanted to see the pictures. The picture's a good one. So here's the picture. This is a motherboard. The yellow is the motherboard, and then you have these transistors, these wires. Below this silver part is a heat sink. This is a type of heat sink too. These little walls. And what they mean by cooling by convection is that the heat goes up through these little metal walls and disappears. The fan is here to help blow the heat off. So as it kind of comes up through the metal, it pushes the heat away to keep the CPU, which is below this in the socket, it's below it, so it blows it away. So that's like on a motherboard. Let's see what else is here in the pictures. That's the only picture that used to us here. So that's the phone. I guess we'll go back. Here's another picture. That's the same one. Hold on. This one's a good one. So here is one that has just a little different design, but the fan is used to blow it out. There might even be a little bit of water in there. So hopefully that helps. That picture, hopefully seeing a more realistic picture helps you understand this diagram a little bit. So there's the CPU, like the socket, the motherboard. So this is all on top of it. And then that's what helps move the heat away. So fans help passively cool it, and it's going to keep cables away. And then there's liquid cooling systems. PC gaming may generate more heat than basic thermal management can cope with. PCs used for where the ambient temperature is very high may also require exceptional cooling. So when you have a very powerful gaming machine, you need to realize that your processors and graphics cards are going to get hot. So you need to make sure that you keep them cool so they operate and don't shut down. So a liquid-based cooling system refers to a system of pumping water around the chassis. So when they say chassis, it's like the whole case. Water is a more effective coolant than air convection, and a good pump can run more quietly than numerous fans. An open-loop liquid-based cooling system uses the following components. So water loop, pushing the water around with a reservoir, water blocks and brackets, radiators and fans are positioned at air vents to expel the excess heat. And so there's different sizes of water cooling systems. Now we're in the topic 2B. So in topic 2B, it's selecting and installing storage. So we just did power supplies and cooling. Now we're getting into and it's selecting install storage device. So these are devices that are going to store data and store software programs, essentially. So, or your data. So a PC is often a much less, so given a scenario, select and install storage device. So we're going to be trying to identify the correct type of storage device. And give us this intro that a PC is often much less valuable than the data that it stores and processes. This means that the reliability and performance of the devices used to store system files and user files is of critical importance. If these storage devices fail, the PC will not work, as a valuable information will be lost. By identifying the types and characteristics of storage devices, we be prepared to select, install, and maintain them to ensure reliable computing environment for users. So now we're into mass storage devices. So when you hear mass storage devices, we talked about on the first night, non-volatile storage. So the difference, does anyone remember from the first night, what's the difference between only has a small amount of cache, however? Consequently, the operation of the CPU must be supported by additional storage technology. It doesn't have enough of a brain on its own. When a process is executed or a data file opened, the image is loaded from the fixed disk into system memory. Instructions are fetched from the system memory and into the CPU's cache and registers as required. The process is handled by a memory controller. Anyone want to attempt to describe what a controller is? Controller. It's more functional. It's like a functional, let me see. I just want you to understand the concept because it's happening at such a level that they're describing it, but they're not describing it clearly enough for someone who might not ever, and then not And I want to see if it's in BIOS. So it's in the firmware. Our BIOS, so here's an example. BIOS has controllers, and we were just talking about the basic input-output system of BIOS. BIOS itself, which is like the base level where stuff starts getting put onto a computer, has what you can consider a controller. It's a set of instructions on a chip. So it's like basic instructions. Do this with this. And in my head, another example of that would be a process handled by a memory controller. So do this with this is the controller piece. The process is probably the higher level topic. So there are multiple processes, of course, and there are also multiple controllers, but you can have more processes probably handled by specific controllers. I know that might have made it more confusing, but I just like the process is happening with a controller. Do this with this. Not that it's going to do it super the way it's done. It does what it's told, but it needs to have specific instructions. System memory is implemented as random access memory. RAM is faster than the flash memory used for SSDs and much faster than HDD, but is volatile, means the memory device can only store its data when it's powered on. Then we have virtual RAM. If there's not enough system RAM, the memory space can be extended using disk storage. Here's the swap space or virtual RAM. The virtual memory, the OS assigns memory locations to its processes in 4 kilobyte chunks called pages. The memory controller, here's memory controller again, moves inactive pages of memory to the swap space to free up physical RAM and retrieves pages from the swap space to physical RAM when required by process execution. So as processes are completed, and it's like a little business in there. An excessive amount of such paging activity will slow the computer down because disk transfer rates are slower. So everything does get slower, but it still works. It's still moving forward. The bus between CPU and memory controller and memory device consists of a pathway and an address pathway. So here we have a little description of address space. The bus between the CPU, memory controller, and memory device consists of data pathway and an address pathway. The width of the data pathway determines how much information can be transferred per clock cycle. That's the data pathway as a highway. In a single channel memory controller configuration, the data bus is usually 64 bits wide. The width of the address bus determines how many memory locations the CPU can keep track of, and consequently limits to the maximum number of amount of physical and virtual memory. A 32-bit CPU with a 32-bit address bus can access 4 gigs of memory address space. In theory, a 64-bit CPU could implement a 64-bit address space. But most 64-bit CPUs actually use a 48-bit address bus, allowing up to 256 terabytes of memory. And for those who remember it, that's why when Windows upgraded from 32 to 64, I think they didn't have much of an issue because it was not as big as it sounds, John. So 32-bit CPU, 64-bit CPU. We have a 64-bit data bus, 64-bit data bus, but we're getting fewer here. We have 3. Here with the 48, we have 7. And then we have the paging activity between the pages. So here we have 256 terabytes virtual memory in that address space. Here we only got 4. And then you have your mass storage. So the computer's trying to think, but you can see that 64 is almost twice as much thinking, right? It's doubling. And what that relates to is actually the paging of accessing memory locations and looking for different things as the computer's processing. So a 64-bit CPU can address more memory locations than a 32-bit. The 64-bit data bus is the amount of memory that can be transferred between CPU and RAM per cycle. And that's the point, is CPU and RAM per cycle. So how well is the CPU functioning with the RAM, right? And specifically, as we're talking about the space, memory controllers, and that's what's giving it power. The CPU. So what I would say to that is, people will tell you, oh, you can upgrade your computer by just doubling the RAM, and that's true. You can double the RAM and keep the local storage the same. But if your CPU is too old, you may still have some of the same issues. You don't want to be on an older CPU. You wouldn't take a 2007 Dell and put 64 gigs of RAM on it and expect it to be like a Windows 11 machine. You know what I mean? That's, I mean, like, just food for thought. You can't just take any old computer and with the same motherboard it had for years and upgrade the RAM and think it's going to be a better machine. It needs a CPU that can process at the speeds you want it to process at and run operating systems. And that's why people have to update their Windows all the time. Because so Windows 10, why, and I might hop to the questions real quick, but just to close the night off, but why are we pushed to update operating systems all the time? Why do we think? Who's working together to do that to people? But it's also good, but there's pros and cons. Why does Bill Gates is working with the processor makers? So when Bill Gates gets around a table with the processor companies, he can basically say, okay, and they can say to him, all right, we're going to come out with a new Intel processor, right? And it's going to be this speed. All right, let's build the next version of Windows to be at that speed. Let's make it work. So now everybody who goes out to buy a computer, who wants the best new Intel chip or whatever chip they're buying, is then going to buy the new HP, Dell, or whatever manufacturer. This is only like 4 now, right? They've sucked everybody out of the business. Or your iPhone and or Google phone, because there's no other option either. Go buy your computer with the new chip. But guess what? You're going to have to upgrade your Windows operating system or nothing is going to work and your computer's not going to be secure. If you want to have a Windows operating system. So then your Windows edition, you have your home edition, you have your enterprise edition, every business is upgrading. And so you'll often see chipset companies and their development kind of also mirroring Windows 11 because they have to, so that the technology continues to kind of keep evolving. It's like a money printing machine for Bill Gates, if you're going to Windows. And because you're basically saying to everybody every couple of years, all right, time to upgrade. So you need to buy the new license and we can change the way you get licensed. So it's all about that chipset, that CPU processor, ultimately needing to run at a certain rate. So just quickly here on this page, we have some, if you want a video, we do have double data rate, makes 2 data cycles. So there's dynamic RAM, storing electrical charge within a single cell. We have synchronous RAM, which is DRAM, SDRAM. Speed is synchronized to the motherboard system clock. And then, we'll review this. Also, DDR2, DDR3, DDR4, which are different versions of bus speed and RAM and memory within devices and, data rates between RAMs. If you ever want to learn more about this, then CompTIA can show, Linus Tech Tips has awesome videos on this topic around reviewing the speed of different RAM and how it works in different systems. But it has a different data rate, it has a different transfer rate and maximum size. And the transfer rate is the speed at which the data can be moved by the memory controller. But I do want to get us into some questions. Memory modules. So these are memory modules called inline memory modules, DIMM. The notches and the keys on the memory module and connector identify the DDR generation. So the connectors at the bottom tell you what version of DDR3, DDR4, DDR5 it is. So these are called DIMM, and they all have different amounts of RAM, 4, 8, 16, 32, different amounts that fit different circuit board sets. Okay, that's, see that the DIMM's DDR type must match the motherboard. You cannot install DDR5 modules in DDR4 slots. So if you're going to upgrade the RAM, just make sure you are picking the right kind of RAM. Also, same bus speed as the motherboard. Small SODIMM, it's kind of funny. System memory from form factor designed for use in laptops. Laptop RAM is packaged in smaller form. Some of that's more money. Some of that's to just make everything smaller and more concise. Small outline DIMM. Let's get to some questions. Multi-channel system memory. Single channel memory means that there's one 64-bit data bus between the CPU, memory controller, and RAM devices. What we'll do is we'll remove them all at once so that we have them all in the video. Single channel means a one 64-bit Dual channel, there are two 64-bit pathways. And then you can see the differences here, motherboard, and then you can also see where the RAM goes in these slots. Channel B, channel A, it pops in, you pull the pins on the side. Motherboard DIMM slots, dual channel, slots 1 and 3, black slots make up one channel, while 2 and 4, gray slots make up a separate channel. So you see the gray and the black. Let's keep going. ECC RAM, error correcting RAM, is used for workstations and servers that require a high level of reliability. Most types of ECC are supplied as registered DIMMs. It uses extra components to reduce electrical load of the memory controller. Both motherboard and CPU must support ECC for it to work. Most motherboards support either UDIMMs or RDIMMs, but not both. If a motherboard does not support both, they cannot be mixed in the same motherboard. Maxing non-ECU DIMMs and ECC DIMMs is not likely to work. So we covered a lot tonight. Topic 2D, install and configure CPUs. All right, let's do some questions, and then here's what we'll do. Do the questions, and then I'm gonna keep recording, and I'll make the video cover 2D. I'll go back, okay? Because that way you'll have questions in this section of the video, and we can kind of do them together. I'll kind of just cover I'll keep the video flowing. So I'm going to move ahead. So this is 2D. This is configure motherboards and CPUs and add-on cards. All right. I'm going to say medium. But we need to skip ahead because we're going to do the questions because I want you to see the questions. CPU talk. So we might. So all right. So we end CPUs and motherboards. So there wasn't that. This is what's left. Is that 2D. So I'll go back and do 2D. So we're going to go to assessments. Well, we're going to practice, and we're going to do installing system devices. Let me pull my window out so I can see your responses in the chat. So, all right, here we go. Practice category. All right. A hardware technician is scanning a computer's non-volatile storage device for errors and infections. Which of the following will the technician include in the scanning? Hard disk, solid state, random, mass storage. All right, I'm gonna go with the first answer I see every time. All right, so it was also, here's an important CompTIA thing, I should have read it to you, that select all that apply. Be sure whenever you get a question that says that, there's always more than one answer. So it's hard disk, solid state drives, and mass storage. It is not random because that is RAM that requires power. So they said non-volatile. Just notice the non-volatile is the way to answer that one. All right, next question. A hardware technician is upgrading a device with multiple identical CPU packages. What class of computer is the technician most likely upgrading? Multiple identical CPU packages. So we think, is it up? They don't say all that apply. Oh, that's probably the last question, sorry. So everyone's thinking D, so we'll go D. Very good, got that right. So that is a technician is upgrading a server class computer. Multi-socket, meaning the technician can install multiple identical CPU. Very good. We talk about desktop. Which of the following central processing unit CPUs architectures implement a system on chip SoC where all the controllers, including video, sound, networking, and storage, are part of the CPU? All right, now I'm going to put C. I'm going to go with, oh, it was D. So what is D? So D is ARM. Advanced RISC machine. ARM designs implement an SoC, which means that all the controllers, including video, sound, networking, and storage, are part of the CPU. ARMs were originally used in phones, and then they got moved to Chromebooks. So they're like a super small system. That's the movement of technology, right? Every 2 years, everything's going fast. A hardware technician is purchasing mass storage devices and tells a salesperson they must use flash memory technology. What type of devices will the salesperson show the technician? HDD, SSD, yes, good job. Solid state drives use flash memory, implement persistent mass storage. An employee is leaving the company and must return any removable storage devices they may have. What devices will the employee most likely return? Select all that apply. So we have more than one. Jackie said B and C. Anyone else in the B and C family? We'll go with that. Correct. So the will most likely return universal serial bus drives, which are a type of flash drive and are simply a flash memory board with a US connector and protective cover. A hardware technician is inspecting the notches on a dual inline module edge. We just read this. What will the notches on the edge connector help the hardware technician determine? Select all that apply, except A and B. That was the first one I saw. So DDR generation, and if it's compatible. Oh, and C, how to insert it properly. And so that's a good example of a kind of tricky CompTIA question. Okay, just always make sure, like, you're going to always be hedging your bets by include it because it's correct, or is it too far off? And you'll figure it out. Like, you'll kind of start finding the line where, like, oh, that's important, but it's testing what you know. An engineer has this new computer system and wants to provide active cooling to improve airflow and dissipate heat from around the components. What will the engineer use in the system? So this is what we started with tonight. I'll put fans in there. Fans is correct. Engineer will use fans to actually improve airflow and help to dissipate heat. Engineers use fan on the power supply and chassis exhaust ports. A hardware technician is reinstalling a heat sink with a central processing unit. Which of the following steps should the technician take to reinstall the heat sink? Select all that apply. Wear an ESD strap. Oh, it's all that applies, so it's more than one. A, B, D, clean it, apply thermal paste. A, B, D. I'll see what this is. That is clean it, apply thermal paste, wear an ESD strap. So that's one of those ones where they, even though it may have been at a 45-degree angle at some point, it wasn't considered like something to include in the. If reinstalling the same heat sink, the hardware technician should clean old thermal grease from the surfaces of the heat sink. A technician is installing a new RAM in a company's workstations. The IT supervisor insists on ECC RAM, which we just read partially, to ensure high levels of reliability. Which of the following statements regarding ECC RAM is true? All that applies. So we have more than one. What do we got? What are we feeling? I see some things C and D. That is motherboards are designed to do that. We try that. That is correct. So motherboards are generally designed type of DIMM, UDIMM or RDIMM, and not for both. Mixing non-ECC and UDIMMs and ECC UDIMMs in the same system can lead to compatibility issues and is not recommended. And then there's always a little extra here if you want to take a look. All right, we'll keep going. A hardware technician is building a server that will process financial data in real time and wants to use error correcting code, ECC RAM, that will detect and correct errors. If possible, what other considerations will the technician need to include to support the ECC RAM? Select all that apply. So it's getting used to that type of question because a lot of lessons don't have that many. So everyone, it's okay to guess. Definitely okay to guess at this stage. Like, you're getting used to the content and you're getting used to the questions. So the only way you're going to learn is to guess. So just try to always have like an educated guess, like a guess based on that you think is right. So ECC capable motherboard, 2 data bus, and we'll get the definition. We'll figure it out. So the one we were missing was D. So the motherboard must have, and usually the first line is the most important to the answer. Just so you know, the other information is generally additional. The very first line in those responses is generally the thing to really remember. The reason why I'm not reading them all is because in the past I've read them all, and what I find is I would overwhelm you if I read them all. It's like more information you need right now, but the very first one is always the one to cue in on no matter what. Must have a memory controller that is capable of supporting that, so that's A. Technician will need to include a 72-bit data bus, and then two 64-bit data buses. So the dual channel. So, and it's okay to guess, trust me. Doing this is going to improve when you take it the first time, totally too. A system engineer is configuring fault tolerance with a configuration that uses a logical striped volume with 2 mirrored arrays. What redundant array of independent disks is the engineer using? So this what you want to do with this question is logical striped volume with two mirrors arrays. CP 1+1. Well, I'll say RAID 1 just to get us in there. It's D. So it's RAID 10. So that's the nested RAID, which combines a logical striped volume. And so the 1+1, yep, that's a good way to remember it because you're kind of understanding the technology. There's a nested RAID configuration that combines a logical striped volume with the two mirrored arrays. And that's D, RAID 10. A student is learning about computer hardware and the instructor selects them to identify the component that executes program instruction code. How should the student respond? All right. A, it is CPU. They should respond with CPU or central processing unit. The CPU in a computing device executes the program instruction code. As part, I just want to get us through as many of these as we can. As part of the tech security, a technician loans a laptop to employees when they conduct business travel. And upon return of the device, the technician reformats the drive and reloads the operating system and all relevant software. After several years of following this process, the laptop becomes sluggish or freezes up. What component is likely causing this kind of behavior? I'm going to go with C. It's B, SSD, they say. So they're saying the state drives. A lot of people get that wrong the first time. Use flash chips that are susceptible to a type of degradation. It's not even something that we even include a lot in the chapter. Over the course of many write operations, which cause the laptop to be sluggish and freeze. So that's kind of a little tricky one. A hardware technician is ordering power supply units for the organization's desktop computers. So power supply units. Most PSUs designed for use with desktops are based on which form factor? This was like our first thing we talked about. Hey, yep, ATX. There we go, ATX. The technician is looking for PSUs that have advanced technology extended specification. A hardware technician is purchasing more servers for an organization that needs to ensure the power supply units in the data center have the correct output to support them. What is the power supply unit output capability measured as? Go with D. D it is. Wattage rating is the measurement of the power supply unit's output capability. Servers have units rated over 300 watts to meet the demands of multiple CPUs, additional memory modules, etc. So here we go. I know we're grinding it out. Just one or two more minutes and we'll be done. I'm going to have you do the attendance form too. I'm going to pop that in the chat right when we have like 2 more questions. A technician installed a new power supply unit in a workstation and removed any unnecessary power connector cables. What type of PSU did the technician install? We did talk about modular. It was modular, which has a detachable power connector that allows the technician to reduce the number of cables to the minimum required. Very good. A hardware technician is tearing apart functioning computer to salvage parts and pulls out a memory stick that synchronizes its power to the motherboard system clock and has a peak transfer rate of 1600 megabytes per second. What type of memory has the technician removed? It is C. RAM is double dynamic random access memory, DDR, SDRAM. It makes 2 fast data transfers rate at least 100 megabytes per second. Okay. Hardware technician is working on a new desktop with memory that can send 128 bits of data per transfer rather than 64-bit. What is this referred to? Say dual? Yes, dual channel. This channel memory controller, as there are effectively 2 64-bit pathways through the bus to the central processing unit, meaning that each transfer can send 128 bits of data. We're learning tonight. This is good. This is where I'm remembering when we went over it, which is good, right? If you don't remember when you went over it, you can get a little lost. A software developer is creating an application that will run multiple parallel threads through the CPU at the same time to reduce the amount of idle time the CPU spends waiting for new instructions to process. What type of process is the developer taking advantage of? I'm going to put the B, the multi-threading. It's multi-threading. It's taking advantage of multi-threading, which is when the software runs multiple parallel threads to the CPU at the same time to reduce idle time. 90% complete, 95%. To mitigate the heat at a high-end gaming system will generate, an engineer is using a liquid-based cooling system in the design. which of the following components are not part of an open loop liquid-based cooling system? Which is not part. This is a fan. Yeah, let's try it. Oh, fan's the obvious answer, I think. Nope, it's something else. It's B, traditional heat sinks. So traditional heat sinks are not part of a liquid-based cooling system. A heat sink is a block of copper or aluminum with fins which expose a larger surface area around the component here. Now I don't feel like they spoke to that specifically, but you have to like deduct it from what, yeah, a little bit. All right, so we did pretty good. 65 first time. If you felt like you knew a lot of those, like that's a pretty good for the first time. I like the fact that we did do the review of the reading before we're doing this, because I think it can sometimes be hard and torturous the first time to go through things alone and then take the quiz and then feel like you might not be learning or doing as well as maybe other people, where I feel like if you can fill out the attendance form, I just popped it in. I'm going to email everybody tonight the document that I was working on with the Google Doc with the stuff we've done this week. But I'm glad we spent the time doing what we did, because actually in some ways it's a little more efficient than even if you had done it on your own. Because what happens is people break off into groups on their own, and then if you don't feel good about what you learned, or this way we're covering a lot and we know we're diving in deep. The shift to be, once we get our access going, is I'll be kind of pushing you to do assessments more on your own, and I'll be giving you time, like an hour at least, classes, like an hour to do assessments and practice them and improve them. So the good thing about this time and the beginning this week and probably the beginning of next week is like we're going to go through the lessons really fully. So, and you'll have I'm always going to record the questions, so I'll get that to you tonight too. So for the weekend, you'll have both links to the recordings on this document, and I'll put this in an email. So I'll send everybody to whatever they use when they fill out the form, because I think I asked you for an email on the form. I'll go into the form and I'll email everyone's email that is this document with the video link. It takes only about 10 or 15 minutes after the video is done to become a link. So I'm going to stop recording now and we'll do that. And I'll email all of you.
So there you go. That is the lesson 2 review with lesson questions. Feel free if you have any questions about any sort of CompTIA resources or ways to prepare a study, feel free to reach out. Check out other videos on my channel, and feel free to utilize these questions to study for yourself, and also review additional supportive text to help reinforce concepts around all of the lessons that are part of the Core 1 and the Core 2. So thanks for watching. Please subscribe if you get a chance, and look forward to seeing you soon.